So summation notation or sigma notation is a convenient way, and it's an important way to represent the sum of a sequence. And we call the sum of a sequence actually a series. But let's look at the notation. The letter sigma is just a Greek letter, and we use what's called the index to determine what our subscripts are going to do and where they're going to go. So if I just look at this, it tells me that I'm taking a sum from index or I equals 1 all the way up to I equals n. It could be any number, okay, a counting number of a sub I. And what you're doing is you're taking that I value, you're starting it at 1, and you're plugging it in. So the first number in the sequence is going to be a sub 1, or in the series, I should say. Okay. Well, then we're going to come back and look at this, and so I was 1. Assuming that n is some number greater than 1, we continue to count. Okay, so our next number, once we've done with 1, is going to be 2. We're going to increment it. We're going to add 1 to it. Okay, so it's going to be plus a sub 2. Change it again. We've used 2. We'll go to the next number is 3, a sub 3. And we do that until we get to whatever the value of n is. Okay, so let's just say we had the summation from I equals 1 to I equals 3. And we actually would write that typically, not that way, but we would just up here put a 3. Okay, just redo that. Okay, so from I equals 1 to 3, and the term that we're summing is a sub I. Okay, so it's going to be, we're going to start at 1. A sub 1 plus, increment the counter, I is now 2. 2 is still less than 3 or equal to 3, so that's okay. So we put plus a sub 2. Increment the counter, we get 3. 3 is less than or equal to 3, so we're going to include it, plus a sub 3. Come back here, increment the counter, I is 4. 4 is not less than or equal to 3, so we don't include it. So we're done. So this summation would represent the sum of these 3 terms. So let's practice. I'm going to do the first one, and I'll leave the other 2 for you to work on. Sum from I to 1 of 3i. Well, we're going to start at 1. So our term of our series is going to be 3 times 1 plus, now we're going to increment I is 2. 2 is less than or equal to 5, so we're okay, plus 3 times 2. Okay. Increment I is now 3. Less than 5, we're okay, plus 3 times 3, and so on, plus 3 times 4, plus 3 times 5. Now, once we do 5, 5 is less than or equal to 5, so it's okay. We're going to come to I equals 6, which does not fit within this range of numbers, 1 to 5, so we don't include it. We're done. So now we can just simplify. 3 times 1 is 3, plus 6, plus 9, plus 12, plus 15, and that's going to come out 27, 36, and 45, I believe. And that would be the sum. Okay. Properties of sums, very similar to what we've seen before. If C is a real number, we're summing up C. Okay, so think about what this may look like, a real number. Let's pick one, 5. Okay, so we're going to sum up from K equals 1 to K equals, I don't know, let's just say 3 of the number 5. Notice that there's no reference to K in this term. It's just a constant here. Okay, so this is going to equal, if K is 1, this term is 5. Okay, increment K is 2, it's still 5. And if K is 3, it's still 5. And we stop there. Okay, so it's equal to 15. Notice that is 3 times 5. Okay. If you have a real number multiplied by some variable with the subscript of K, you could take that constant out of the summation and put it out front. Okay, and just take the sum of the variable and then multiply it by that constant. If you have the sum of two variables, okay, you could break it into two separate sums, and the same thing for difference. You could break it into two separate sums. Notice that the limits, which were from 1 to n, stay the same for each of the sums that you've broken it up into. We talked about finite versus infinite. Okay, the summation, as I mentioned, is known as a series. An infinite series would be one that doesn't end. In other words, n is infinity. Okay, we could still sum a series that has an infinite number of terms. There are a few techniques we'll look at. Okay, the first thing I want to talk about though is partial sums. Okay? The third partial sum means the sum of the first three terms. Okay, so here we have a sum. I is going from 1 to infinity. It's an infinite sum of 3 over 10 to the I. So let's take our third partial sum. Our first term is going to be 3 over 10. Okay, our second term is going to be 3 over 10 squared, and our third term is going to be 3 over 10 to the third. Now this is going to be easier to look at in decimal form, so I'm just going to convert it quickly. 3/10 is 0.3, 3/100 is 0.03, and 3/1000 is 0.003. Well, if we add those up, you get 0.333. Not repeating, just 0.333. For part B, we need to think about what's going on here. And if we think about what's going to happen, this is going to continue. I'm going to just write it up here. This is going to continue plus 3 over 10 to the 4th, plus 3 over 10 to the 5th, plus 3 over 10 to the 6th, and so on. Okay, so this sum is going to become 0.3 plus 0.03 plus 0.003 plus 0.0003 plus 0.00003, and so on. And you can see what this is going to is 0.3 repeating, or 1/3. Okay, so that would be the sum. If I added up all infinite number of terms of this series, the sum of the infinite series is actually converges to 1/3.